Okay, so it is on page 24. What? Yeah, they're not. Um, so let's actually take a look. I want to start by looking at the example down here. Kind of will help make sense to you if we kind of look at it with an example. So let's look at the example 1 down there at the bottom of page 24. So this is where a company institutes an exercise break for its workers to see if this will improve job satisfaction as measured by a questionnaire that assesses workers' satisfaction. Scores for 10 randomly selected workers before and after the implementation of the exercise program are shown in the table. All right, so when we first look at that data, we have two sets of data. Okay, so you see that we've got data that was taken at this particular time and data that was taken at this particular time. What is different about this than what we had done yesterday? What? Okay, yesterday we had two sets of numbers also. Yesterday, remember, we had two separate means. Look at this. Oh, sorry, go ahead. For one worker, we have a before and then an after. So what happens is that we can have a benefit from that. So let's talk about that. Look at these before scores. There's lots of things that could be going on in these people's lives that are making it go from score of 15 job satisfaction to a score of 45 job satisfaction. So they start all over the place. What kind of things could be contributing to that wide range? Just their what? Their morning, when they took the test, okay? Maybe the department that they're in. Maybe one department likes their job better than another department. Male versus female. Just generally happier with their life. Some people just generally have a different scale. You know, some people think an 85 is a really good grade, and some people would like freak out if they got an 85 for a really good grade. You know, that kind of thing going on. So same thing here. So there's so many variables going on that if we just picked 10 people for the first score and 10 totally different people for this second score, what could happen? What could happen? What if I happened to get just a whole bunch of 10 happy people right here? I just happened to get a whole bunch of 10 really happy people right here and just an overall 10 randomly selected sad people here. What will it make it look like? Yeah, it'll make it look like the exercise program works when it's not really. Okay, so the good thing to do is to reduce all those variables and to just pair up the people's own score. What happens whenever I just pair up this person's before with this person's after? I'm really actually only interested in the what? The difference. Very good. I don't care where this person started or where this person ended. I care about what the difference was. This person went down 1. I don't care where this person started or this person ended. This person went down 4. I don't care where this person started or this person ended. This person went up 6, and so on. So the actual beginning and ending aren't what's important. It's this change. This one set of data, this one set of differences is what's important. So yesterday we had two separate means. Today I am really back to being only interested in one mean, and I'm interested in the average of these differences. So I don't want to know anything here or here. I'm not going to do two separate tests, two separate means. I'm going to just get one average off of that list. Okay. You see how that could be beneficial? Having it be the same people before and after. So if we take a look up here at the top, we'll talk about what this is called. If you know that you have data that is paired, or you can make it paired, then you want to take advantage of that, because you could have a before group, before the treatment, and then after the treatment. And you have the ability to match up the data so you compare the exact same subject before and after. So can you see how this would be a huge benefit? Because it would really do what to the variability? What would it really do to all those variables? Yeah, decrease them. I mean, you can't ever say 100% eliminate them, but it would really decrease a lot of variables. The foundational traits remain the same for each subject before and after. Therefore, you have essentially eliminated, you can never say completely eliminated, any unknown lurking variables. All right, so on these ones, when we check the conditions, how many groups do you think I'm going to have to check the conditions for? One. We're back to conditions for only this set of data right here, only the differences. So that's nice. Okay, so when we do that, we want to say that we're randomly selected people or whatever. Independent, again, N is less than 10% of the population. But here is what's different from before. Okay? Note, are the two groups independent of each other? Is this before group separate from the after group? Yeah, no, they're directly related. I mean, they are the exact same people. So you can't say before and after are different, independent of each other people. Here's where independence comes in. What you actually check is that the results of one pair, one of those persons, one of those workers' data is not affecting the results of the other person's data. So you're assuming that those randomly selected people are not those pairs are not affecting each other. Okay? So from pair, this person is not affecting this person. And those results are not affecting those results, and so on. Okay, and then with our large enough, we go through the same process of maybe have to draw a dot plot if we don't have it large enough, and so on. The nearly normal model applies. Okay, so let's talk about how this is different. Again, now we have only one set of data, whereas yesterday we had how many means? Yesterday we had two separate means. Mean for the men and a mean for the women. The mean for the by-right fish, the mean for the fish friends. Okay, so two separate, totally separate groups. So here we have just one mean, and it's for those differences. So mechanically we will be doing a one sample T-test or a T-interval for, and we'll call it for paired data. So one sample T-test or T-interval for paired data. Okay, and the sample size is the number of pairs. For example, down here, what's our sample size? 10, because we have 10 workers. Furthermore, what's our degrees of freedom on this one? Good, it is 9 as well. Okay, so let's take this problem and let's go on to doing the interval and the test on the top of the next page. Okay, so here we go. Identify the procedure that you would use to assess that effectiveness. So we want to talk about what is that, let's see here. I've got this written out so I don't have to. So we're going to go ahead and do this. Here I'm going to show you how we would write the parameter because it's different than we've written before. Okay, so take a look here. It is one mean. So it's mu, and then we have the little subscript A minus B because we did the after minus before. And I'm going to talk to you about why we do after minus before in just a second. So it's the average of the differences. It's the average of the differences in that third column of job satisfaction of all workers at this company who participate in the exercise program. Okay? So we have one average of the differences in job satisfaction of all such employees that participate in this exercise program. Now let me kind of tell you why it makes sense to do the after minus the before. Okay, I'll show you why it makes sense to do the after minus before. And it has to do with the sign that you get, whether it's a positive or negative number. So for example, down here on this previous page, see, look here. 30 to 33 went down 1. And we got that down 1 by doing 33 minus 34. So by doing the after minus the before, this sign that we get here is intuitive to what happened, what effect occurred. See, 41 minus 27 is how we get this 14, and it went up from before to after, went up, increased 14 points in job satisfaction. So that's why we do typically the after minus the before. All right, so back here. So that's how we write that. So now, how would I, for a null hypothesis, how would I indicate that there is no difference in the change in their job satisfaction? Yeah, the mu of the A minus B equals 0. You see, again, there's only one mean. And then if I have improvement, what kind of difference do I have? If I have improvement in job satisfaction, greater than 0. Okay, so there's our null and our alternative. Okay. Let's go ahead, because there are few little things I want to talk to you about on the conditions. I mean, I wouldn't do them if I didn't think we needed them, and so there's a few things I think we need, so let's do them. So first, what would we say about this group of 10 workers? Good. Randomly selected workers stated. Oh, I don't know if they were stated, maybe. Assumed or whatever. Okay. Now, independent. Independent, how many do we have? 10 is less than 10% of all such employees or workers. And then here is, it's hard to see here, so let me circle it and tell you what it says here. This is that extra added little thing here. Each pair is independent of each other, or each worker's results. That would be good to say. Each worker's results are independent of each other. Each worker's results are independent of each other. That would be a good way to put that. Each worker's results are independent of each other. So is it large enough with having a sample of 10 workers? Nope. So it didn't say up in the problem that it's normal or approximately normal, so guess what we get to do? Dun, 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 dun. We get to draw a picture, and I'm going to do this with you because we got negatives and positives to deal with, so I want to just kind of walk you through handling that. Okay, so let's talk about it. We're going to first go ahead and draw ourselves our little situation here. So tell me, what is that data that is in that third list? What kind of data? It's the what? Very good. That data that is in that third list is the differences, or you could even say change, in job satisfaction. So the difference in job satisfaction, after minus before. You do not put down there its job satisfaction score. No, it's the difference in their job satisfaction score. Okay? And then what are the counts? What are each one of the pieces of data coming from? An employee. So over here is my number of employees that have those particular score differences. All right. Now, let's actually go to our calculator for a minute because I've kind of not had you do this. Let's go ahead. Where are we going to put all this data in? Stat edit. So I want you to go back to your data or your lists. Okay, on the bottom of that page there. Take a look and let's put this information right here. Put the before data into list 1 and the second data into list 2. The after goes into list 2. And after you get that, then I'm going to show you how to let the calculator compute the third list on its own. Okay, so go ahead and put those in there. L1 is the before, L2 is the after. Okay, so after you have that in there, I'm going to go over to list 3. And I'm going to put my cursor on top of the L3. Okay, put your cursor on top of L3. And we need to command it to do some math here. What do we want to tell it to do? L2 minus L1. So our cursor is on top of the L3, and we're going to go second L2 minus second L1 and enter, and then voila, all those differences go in there. Now, a mistake that could occur is if you had mismatched amounts in each column, L1 and L2 didn't line up. They could say dim mismatch error. Okay, that's a common error that could happen. So again, we're not interested in L1 or L2. We are interested in L3. And so when we come over here and plot our data, we are going to be plotting the data in list 3. Okay, that's what we're going to be plotting. So the numbers in list 3 go from what's the low bound to the upper bound. That's the lowest value. Okay, -4 up to 21. So 21 minus -4 is a spread of 25. So how much should my bins be? 5. Make your bin size 5. What are you going to start with based on what the lower value is there? Yep, I'm going to start with -5. So you can see then what is happening is this vertical line that I have my number of employees, that's technically not you're doing this at the bottom of, or on that page 25. This vertical line here isn't really the origin. Okay, so I've got -5, and then here's my 0, and then my +5, 10, 15, and so on. Okay? All right, so I want you to take just a moment, put those things in there, and see if you get what I get as far as our dot plot goes. Yes, ma'am. So, you know, after we get that list, what kind of things then are we going to say about this? Somewhat symmetric, unimodal, and no outliers, so it's sun. And then nearly normal model applies. Okay? And then that's the end of our conditions. Nearly normal model applies. All right. Good. So I wanted to point out to you, the reason I said let's go ahead and do this dot plot is because you might have this situation here, this kind of unusual situation where you have negatives because you have a negative difference there. Okay, so do be aware of that. All right, moving on. Let's finish this thing up. So let's go ahead and perform a test. And what kind of test do you think this is that we are going to perform with our data? Yes, it's not two means that we are dealing with. So it's one mean that we are dealing with. So it is just the t-test. It is just the t-test. So you have just really got to keep straight in your mind. Two means or one mean. Two means or one mean. Here we have our information under data because we put it in the list. Okay? The null hypothesis is a 0 because it was about a 0 difference. And which list of data am I interested in? L3. So make sure that that says L3. Our frequency is 1. Your tail is greater because we wanted to see job improvement, and we're calculating. And so we get a t-score of 3.6. Okay, we're going to get a t-score of 3.6, a p-value of 0.03, and must include the df. Don't forget that. Don't forget the df. See, don't forget the df. Okay, all right. So now let's do our conclusion. Or, well, we'll go ahead and compare to alpha. Hey, you know, there is something I've seen creep up on some of y'all's papers. Some of you have not been telling me, you know, you'll just say 0.003 is less than 0.05. And never anywhere on your paper I searched did you define that alpha is that value 0.05. Just don't leave off that symbol, alpha being the 0.05. 0.03 being less than 0.05, we reject HO. So here's how we're going to say that. Since the p-value is less than alpha, I reject, and so I write down the symbols for the rejecting. The mu of A minus B equals 0. Okay? Now your second sentence is about HA. Therefore, I have evidence that the exercise program increases the average difference, because that's what this problem is about. I have evidence that the exercise program increases the average difference in job satisfaction. Okay? All right, and then we're going to go and run the t interval for the next part. So we're just going to go down there to, in the calculator, do the t interval. Oh, do you know what? I forgot to tell you what we were supposed to write for this one. I left this part off, didn't I? One sample, don't forget, so somewhere in there, I would have gotten marked off. Put that this is the one sample t-test, not for means, for paired data. One sample t-test for paired data. Okay, that's the name of this. One sample t-test for paired data. All right, so that makes this exercise 2 or example 2 or B, part B, whatever, one sample t interval for paired data. Okay, then you go and do that interval. Shouldn't be a mystery, you know, you go and you got it in the t interval calculator. So do not forget this part right here in front. Since this is about a difference in some information, you have to define which way you subtracted. So mu of A minus B is 2.2 to 14.8. Sorry, 2.8 to 14.2. 2.8 to 14.2. So let's interpret that. What does that mean? If we were now to say what it means, what would we say? Good. I'm 96% confident that okay, but the average difference in job satisfaction. So that's important there. The average difference in job satisfaction. And then I put among all such employees is between, is between 2.8 and 14.2 points. I'm 96% confident that the average of the differences in job satisfaction is between 2.8 and 14.2 points higher after the exercise program. Higher after the exercise program. Okay? And recall that when we have problems about differences, what are we interested in particular about that interval? If 0 is in it. So, then 0 statement. 0 is not in it, so it does give evidence of a difference, something along those lines. So, you can fill that in however you want, 0 statement, da-da-da. Your homework then is pages 26 to 29, but I'm going to eliminate page 28. Page 29 is 2 good multiple choice questions. So you can eliminate or omit page 28, but do pages 26 to 29. Okay? All right, so while you guys are working on that, because you got a good amount of time to do that, a good 25 minutes, over 25 minutes, I'm going to come and stamp you for your things that I've missed stamping you on so far.